Welcome. In this video, we are going to look into probabilities that occur when rolling a six-sided die. First, let's go ahead and describe the sample space. If you haven't seen a six-sided die before, here's one on the screen right now. Each side of this cube is numbered between 1 and 6 using either dots or the numbers 1 through 6. That means our sample space is equal to 1, 2, 3, 4, 5, and 6. Next, part B. What is the probability of rolling a 3 on the next roll? I'm going to call rolling a 3 event A, and in probability notation, probability of A, of this event A occurring, is, well, remember, number of successful outcomes goes on top over the total number of outcomes. So in this case, the success is a 3, and we have one of those, and we have 6 total possible outcomes. So this probability is 1 out of 6. As a decimal, that's equal to 0.1667. Next, let's look at part C. What is the probability of rolling a number less than or equal to 6 on the next roll? So let's call this event here, rolling a number less than or equal to 6 on the next roll, event B. As this problem is stated, we want a number that's less than or equal to 6, so that can be 6, or 5, or 4, or 3, or 2, or 1. So the probability that event B occurs is 1, since it is certain that we are going to roll a number less than or equal to 6 on our next roll when rolling a six-sided die. If you don't see that intuitively, you could work it out by writing the total number of successful outcomes, which there are 6 of, divided by the total number of outcomes, and that'll get you a 1. Next, let's look at part D. What is the probability of rolling a number less than 6 on the next roll? As always, I'm going to label my event first. This is event C. And now we want a number less than 6, so not equal to 6. Notice that this is missing here. So we want a number strictly less than 6. And there are 1, 2, 3, 4, 5 numbers strictly less than 6. So the probability of C is equal to 5 out of 6. As a decimal, that's 0.8333. Next, let's look at E. What is the probability of not rolling a 5 on the next roll? Of course, I'm going to call this not rolling a 5 on the next roll, event D. And there are 2 ways we can do event D. The first way is going to involve the complement. So what is the complement of not rolling a 5? So let's start by writing out event D. Event D is not rolling a 5, so we could roll a 1, a 2, a 3, a 4, or a 6. The complement of D, which I can denote with a bar on top or with a prime, that just equals 5. The probability of just rolling a 5, so the probability of the complement here, is 1 out of 6. And I'll get to writing it as a decimal in a second. So that tells me that the probability of D of not rolling a 5 is 1 minus 1 out of 6. That's because all probabilities are values between 0 and 1. So the probability of D has to be less than or equal to 1 and greater than 0. And this is how we can use this fact to get a probability using its complement. And actually, I should write a little bit more probability notation here. So this is 1 minus 1 out of 6, which is 5 over 6. And that's also 0.8333. The other method you could do this is directly, and I'll do this in blue here, so direct method. And here is using complement. And so our direct method, the probability of D, is count the number of successful outcomes on top, There are 1, 2, 3, 4, 5 of them. And in the bottom, we have all the possible outcomes of the sample space, which is 1, 2, 3, 4, 5, 6 of them. And we get the same answer. I hope you found my video helpful.